Someone give her a microphone.
Sure. In the picture that for the unification process,
Right.
I say that there is some two force or two phosphat binding to the UV phenol. So is it will be depend on the ATP over AMP ratio and to the energy metabolism of the cell?
Well, that's a very good question. Actually, you talk about the ATP ratio maybe affect the ubiquitination process, and this ubiquitination process may be also somehow linked to cell metabolism. We have not done anything like that kind of experiment yet, but certainly the ubiquitination process requires ATP, that's for sure. Okay, and we don't know whether a certain ATP AMP ratio will really affect this. Maybe when it really ATP is really low, that ubiquitination will be shut down as well. And that's what you would expect, but we don't have any evidence to support these here. Okay, so that's certainly an interesting question that you have. So whether this is related with cancer energy metabolism, possibly, because ATP production is required, and then ATP is required for the ubiquitination process. Good, all right. All right, there's a question there.
I have a general question about cell cycle. So I wonder how the cell know when to divide or duplicate.
How the cell know when to divide and duplicate?
Yes.
I think the similar question we discussed yesterday. Okay, so if the cell need to divide, sometimes they receive from the signal, because the cell has a receptor, all the growth hormone receptor, all these cytokine receptor. Okay, so for example, during the embryo stage, there may be the EGF, okay, by activating EGFR, and the trigger all the MET kinase pathway or AKT pathway to stop P27 or P21 say, okay? And then you don't have a break to control that time. And then the cycling CDK will be activated, and then you will have a cell proliferation process, you have a cell dividing process. Okay? So you put a cell in the context that they are receiving many different kind of signal. Could be coming from EGF, could be coming from FGF, could be coming from IGF, IGF2, etc. All these different cytokines in that context determine whether the cell to start to divide or not. Okay. Good. Question there?
I want to ask about stem cell. As we know that cancer cell and stem cell share some common characteristics.
Right.
Both of them are immortal cells, and they have the ability of proliferation unlimited times. So I wonder what is the differences in the cell cycle? What is the different events in the cell cycle of that make them be different? One becomes a stem cell and one is a cancer cell.
That's very interesting question. The cancer stem cell and the other cancer cell. I think the difference there is, the cell, sometimes we're using these the so-called CD marker to tell the difference, whether these are stem cell or not. Right? This is CD marker, actually, sometimes they are functioning as a receptor, so we don't know their biological function yet. Okay? And the stem cell, usually they are dormant, they only receive certain type of signal. Could be coming from like cytokine, could be coming from epigenetic regulation, allow them to become cell be able to start differentiating. Okay, so of course this is not well known yet, and then we do need to make effort to understand more about the stem cell and the other type of cell. The basic is that the dormant situation against the stem cell, as we said yesterday, make them potentially resistant to chemotherapy drug because they are not proliferating at that time. Okay, so the cancer cell got killed by the chemotherapeutic agent, but the